Welcome to The Explainer. Today, we're diving into something that honestly feels like it's straight out of science fiction. We're talking about the power to turn simple, everyday words into complex, real-world 3D objects. I mean, just imagine speaking a design into existence. Take these four simple words: a long, rectangular shape. Now, what if I told you that this one little phrase could generate a precise, fully editable, three-dimensional blueprint for an object totally ready for manufacturing? Well, that is the incredible promise of a new AI framework called Text-to-CAD. All right, so here's our game plan for today. We're going to start with the problem that needed solving, what I'm calling the CAD conundrum. Then we'll look at why this is so tricky to get right, unpack the huge breakthrough that is Text-to-CAD, see how it actually performed, and finally, dream a little about what this means for the future of design.
So to really get why this is such a big deal, we first have to understand the world of design as it is right now.
You know, computer-aided design, or CAD, is the absolute foundation for almost everything we build, from our phones to the buildings we work in. The software is unbelievably powerful, but all that power comes with a price. For anyone who isn't a highly trained professional, it's kind of like being handed the keys to a space shuttle with zero training.
And you know what? Even for the pros, it's a major bottleneck. Prototyping can be painfully slow and tedious, the learning curve is just incredibly steep, and it creates this huge, slow gap between having a brilliant idea and actually holding a functional object in your hand.
And that bottleneck is exactly what researchers are trying to smash. So what if there was a completely different way to do all this?
What if you could just talk to the software? Seriously, instead of clicking through hundreds of menus and tweaking endless parameters, you could just describe what you want, like this example right from the research paper. Generate two concentric cylinders. It's such a simple, intuitive dream, but one that could totally revolutionize how we create, well, everything.
But okay, if it's such a fantastic idea, why hasn't someone done it already? This is where we hit the core challenge, and where we really separate the dream from the tough reality.
And right here, this is the crucial difference. We've already got AI that can make what you might call digital sculptures. They're basically static 3D images that you can't really edit. But Text-to-CAD is aiming for something totally different, a digital blueprint. It's like the difference between having a photograph of a car and having the actual engineering schematics you need to build the car. It's a whole other level.
Now, to get there, researchers had to clear two massive hurdles. First, there was the data gap. There was just no textbook for an AI to learn from, no giant data set connecting simple text descriptions to the step-by-step instructions of CAD. And second, there was the AI gap. The AIs that did exist just weren't built for this. As the paper points out, a vision model might look at two concentric cylinders and, I kid you not, hilariously misidentify them as toilet paper, which, as you can imagine, is not exactly helpful for precision engineering.
So, how in the world did they solve these massive problems? Let's get into the breakthrough that makes all this possible. They built Text-to-CAD. It's the first ever framework that generates these fully editable, what they call parametric CAD models, directly from text. And here's the key. It's designed to understand everybody, from a total beginner just starting out, all the way up to a seasoned expert using complex commands.
So to solve that data problem, they came up with a really clever solution. They had one AI teach another. First, a vision AI looked at thousands of models and wrote a basic description. Then, a super powerful language model took that description and the raw CAD data and wrote out detailed, human-like, step-by-step instructions. And just like that, they created the massive data set they needed, the textbook for their new AI.
Okay, so with the textbook written, they needed a student smart enough to actually learn from it. And that's the Text2CAD transformer. Think of it as a specialized AI that's been built to be the ultimate translation engine, converting our human language into the super precise machine language of CAD.
So, the whole system is built. It sounds great on paper. But does it actually work? I mean, a cool idea is nothing without proof. So let's look at the test results.
The first and most critical test is about reliability. How often does Text-to-CAD mess up and generate a flawed, unusable model? Well, the answer is almost never. Less than 1% of the time. And to put that number into perspective, a previous model called DeepCAD failed a full 10% of the time. That means Text-to-CAD is nearly 11 times more reliable. That isn't just an improvement, it's a massive leap forward.
But being reliable doesn't mean much if you're not also precise. And here, Text2CAD just knocks it out of the park, creating the right shapes way more accurately than the baseline. But look at that last row, the geometric accuracy. Its error rate plummets from over 32 all the way down to just 0.37. It's not just making valid models, it's making vastly more precise ones.
To really push the systems, the researchers gave them a true challenge. This complex, pretty abstract prompt for a symmetrical, star-like structure, and then they put them head-to-head. They even brought in another powerful AI, GPT-4V, to act as an impartial judge, and its verdict was crystal clear. The model from Text2CAD was the one that accurately captured all the precise geometric details from the prompt. It didn't just see the words, it actually understood the request.
But of course, the ultimate test is what human experts think, right? When they asked professional CAD designers to judge the outputs, the results were really telling. For super simple prompts, it was basically a tie. But as the prompts got more complex and detailed, the designers increasingly preferred Text2CAD's models. That right there proves this isn't just a toy. It has real value for serious professional work.
The data is definitely impressive. But beyond the charts and numbers, what does a tool like this really mean for the future of how we design and build things?
Look, this isn't just a small step up. For the experts, it's a massive speed boost. But for everyone else, for students, for hobbyists, for inventors, it completely tears down the walls. It closes that huge gap between pure imagination and a real-world physical object. This could seriously kickstart a revolution in things like rapid prototyping and personalized manufacturing.
And that leaves us with one final, really provocative thought. When the incredibly complex tools of creation become as simple and as natural as just having a conversation, what new things will we design when our own ideas are the only real limit?